So welcome back to the Twitter Think channel, and in this video we are going to talk about complement rule for conditional probability. Remember that in the first introduction to conditional probability, we learned that the conditional probability of two events P of A as B has occurred gave us the probability of A intersection B dividing the probability of what? B. Because we learned that we were conditioning on B. We are assuming that the event B occurred. Look for intro to conditional probability part 1 in the same playlist. That is where we spoke about this. Now we learned that when we interchange this, then we have the conditional probability of B as the event A occurred is the same as the probability of what? B intersection A dividing, because we are conditioning on A, we are assuming the event A has already occurred. We divide by probability of A. What if we are told to find their complement? Complement, that is what we are coming to talk about. So today, what if I tell you to find A complement what? B, or I tell you to find B complement what? A. What formula are we going to use? So let's dive into complement of conditional probability. In this video, I will focus on only one of them. We are going to talk about the probability of the event A complement the event B has occurred. What are we going to do when we have something like this? In our next video, we'll talk about if B is the complement. Before I start, A complement is the same as A bar, okay? I prefer using the bar. I don't feel comfortable using the C. So I'll be using A complement this instead of what? This. They are still the same thing, okay? So you choose the one you want. Now, conditional probability is saying that anytime you have the first event here, the event here, with a complement as the next event has occurred, the easiest way to solve this question is to say that the result is going to give us 1 minus the probability of event A as B has occurred. Just remove the complement from here. Once you are able to find the probability of event A as B has occurred, you subtract that result from 1 and you will get the answer for this. Now know that the probability of A as B occurred was what I explained in the beginning. We did it first. Now we know that it is P of A intersection B out of probability of what? B. We can find this. If the question has given you the probability of B and the intersection or A and B occurring together, it is easy to find this. Sometimes the question that comes, you've already calculated for these values. You just insert it to find this one. All right. So what does it mean? Why are we saying that this formula stands? Now let's explain the reason why this formula stands. Okay. Before we will understand this, I want you to cast your mind here and cast your mind here. Okay. The reason is because we are now conditioning on what? B. So our focus is here. This event has already occurred. The reason why we are saying that the result or the shortcut method is 1 minus this is because the event A complement and A are two complementary events. They do not occur at the same time. So we say that they are what? Mutually exclusive. If this one happens, this cannot occur. If this occurs, this cannot occur. Listen very carefully. It means A complement and A are a subset of the event what? B. Okay, so when we find the probability of B, we will see that the conditional probability of B, we will see that this and this will appear in there. They are two subsets, okay, and they don't occur together. This is happening at one side. This is also happening at the other side. Okay, now we will prove this formula and find out the reason why it is like this. Let's assume that I am told to find probability of what? A complement as B has occurred. Then the conditional probability formula will be the two events occurring together. Probability of A complement intersection what? B divided by the probability of the one we are conditioning on. So it means P of what? B. So now you have been able to code this formula. How are we going to solve for this? So let's consider or find probability of A complement intersection B. Now, that is what I have here. Before we can find this, how do we do that? We need to consider the denominator. Remember that in the beginning, I told you that because of the complementary nature of these two, okay, they are found in the probability of what? B. Remember I told you. So now let's concentrate on what? Probability of B. So probability of B is supposed to give us, now watch, the probability of A intersection B plus probability of A complement intersection what? B. Now what's something? You see that this is now here. So if I want to make this one the subject, what am I getting? I'm getting probability of A complement intersection B is going to give us the probability of B minus the probability of what? A intersection B. Let's label this one equation 1. Okay, and let's label this equation star. I'm going to explain this for you to understand. Now, why is it that the probability of the event that has already occurs is A intersection B, A complement intersection B? You see now, I told you that the complementary nature, this and this, you can see that one is here, one is here. You see, they are found inside the probability of B. That's why this formula holds. Okay, so now let me use numbers to represent this and let's see what will happen. Let's assume that we have two sets. I have A and B with an intersection. This is B, this is what? A. Okay, the members of A are 1, 2, 3. We have 4, 5, 6, 7, and 8. Okay, the universal set is equal to 1, 2, 3, 4, 5, 6, 7, and 8. Okay, respectively. Now, let's do this together. Follow me. Let's find the members of A. Members of set A alone is giving us what? 1, 2, 3, 4, and 5. 4 and 5. Members of set B is giving us what? 4, 5, 6, 7, and 8. Okay, then let's find A intersection B. Okay, and that is what we have here. So A intersection B is giving us 4 and 5. Okay, if that is the case, look at this formula. We need A complement. Okay, so let's find A complement. So A complement is going to give us the universal set minus the event what? A. So when we compare these two, A complement is going to give us what? 6, 7, and what? 8. So 6, 7, and 8. Now watch. Let's find A complement intersection B. Okay, so A complement intersection B is giving us what? Now watch. What is A complement? This is it. And where is B? This is it. So A complement intersection B. What are we getting? We are getting 6, 7, and 8. Let us find out if the formula in equation 1 is true. If that is the case, then let's look for the event B. Okay, so the event B is going to give us, now the formula said that when we take A intersection B plus A complement intersection B, it should give us the event B. So B is going to give us what? A intersection what? B plus A complement intersection B. Now let's put in the result. When we put in the result, we have B giving us what is A intersection B. A intersection B, we had 4 and 5. When we add the result, now we are not going to add the values, we are just joining them together. Okay, that's what it means. Now when we go to A complement intersection B, we have 6, 7, and what? 8. Now look at this result very well and let's compare with the original B. Have you seen they are the same? 4, 5, 6, 7, 8. So that formula holds. Okay, that form. So when we find the probability of that, what is going to happen? The probability of this event is giving us probability of P of B is giving us what? 1, 2, 3, 4, 5 divided by the universal set, or let's say the sample space, which is 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. In the same way, when we find the probability of this, it's going to give us 5 over what? 8. So now I hope I've been able to explain this for you to understand. So don't ask why are we saying probability of B is equal to that. It holds for any variable you are working for. Now let's continue from where we ended. Now this is our original equation and this is equation 1. Let us put equation 1 into the original equation and see what will happen. So this is going to give us the probability of A complement as B has occurred is going to give us what? Now let's fix everything here to replace that. We are going to have the probability of B minus probability of A intersection B, all divided by probability of B. So we have probability of what? B. Now from here you can also use this formula. Let's label this equation 2. Anytime you are solving the question and you know the probability of B, okay, and you know the probability of A and B occurring together, when you use this formula you can solve the question. Okay, so either you are using this or you can apply this one, it will work. But we are trying to prove what we have here. So let's continue. From here, let's consider A intersection B. And let's go back to the conditional probability formula. We all remember this one. Good. When I divide this and I cross multiply, I can make A intersection B the formula. When we do that, what are we going to get? We're going to get probability of A intersection B is going to give us probability of A as B has occurred times the probability of B. So we are going to carry everything that we have here and put it here. Okay, so when we do that, what are we having? We are getting probability of A complement as B has occurred is giving us probability of B minus, let me put this in a square bracket. We have P of A as B has occurred times probability of what? B. Okay, we divide this whole result by what? Probability of B. I hope you understand up to this point. So what I did was that I just found what is A intersection B. Using the probability rule formula, I know A intersection B to be this, so I just replaced it. Okay, now let's carry on. Now when we remove the bracket, what are we getting? We are going to get probability of B minus probability of A as B has occurred times the probability of B itself dividing probability of what? B. Now we have probability of B and probability of B here. They are common. So when we factorize one of them, we are going to get probability of B outside 1 minus probability of what? A as B has occurred. Do you understand? So now when I factorize this one out, this is it. I factorize one of them. I'll be left with 1 here, which is here, and this one, which is here. So when we divide this, we are going to get probability of what? B. Now it is simple. You could see that this can now cancel this. Okay, so the probability of A complement as B has occurred will give us what? This result, 1 minus probability of A as B has occurred. And this is why we said in the beginning that the shortcut method to solve for this is always using this. Unless you don't know this, and if you don't know this, it is easy for you to calculate. Okay, and I've given you some of the rules. I think I cleaned that one. So you can use the conditional probability rule to arrive at this. And if you have this, you just subtract from 1 and you get the result. If you don't have it and you have the event A and B occurring together and you have the probability of B, you can use this formula. It will work. So if there is any other way, I do not know. As at now, I don't know. So if you know something, you can help me. You can also post it on the comment section for people to what to see. So in the next video, we are going to change this and talk about the complement of what B instead. So probability of what P of A giving B complement. And let's find out what the formula will be. Whether it will be something similar to this, we do not know. So stay tuned. Check the second video for this one. My name is Daniel, and this is the end of this one. I'll see you in the next one.